So 7.2 is going to start off similar to how 7.1 ended, where we're evaluating using identities. So the first identity we're going to look at is the cofunction identity, and the cofunction identities are on your formula sheet. And they are written like this. So you've got the sine of an angle plus pi by 2 is equal to positive cos x, and the sine of x minus pi by 2 is equal to negative cos x. So sine, you keep the sign, whereas cos, when you've got x plus pi by 2 and minus pi by 2, you reverse the sign. So what we're going to do in this first one is prove that the cofunction identities are true. In other words, we are going to try to turn sine of x plus pi by 2 into cos x. So the way we're going to do that is we're going to just work with this, and we're going to try to turn it into cos x. So I'm going to look at the sine of x plus pi by 2 as a sum identity. So I'm going to expand it out. So the sine of the first angle times the cos of the second angle plus, because you keep your sign, the cos of the first angle times the sine of the second angle. And then we're going to evaluate. So we can evaluate anything that we know the angle of, so cos of pi by 2. So when I look at the cos of pi by 2, I know that it's equal to x over r. So we've got cos of theta is always equal to x over r. Well, what do I mean by that? Well, let's draw our unit circle. So pi by 2 is up here. It has a point 0, 1. So the x value is 0. The r value in a unit circle is always 1. So the value of cos of pi by 2 is 0. If you don't like your unit circle, feel free to draw your cosine graph, right? So pi by 2 is your first key point here, or your second key point here at pi by 2, which is y is 0. Okay, and then we can move on to the sine of theta, which is y over r. And so if we do that of pi by 2, the y value is 1, the r value is 1, so the value of sine pi by 2 is 1. Again, if you like figuring that out from the graph, do a quick sketch. Here's pi by 2, you have a y value of 1. Okay, so now we're going to put that into here. So we've got sine of x times the cos of pi by 2 is 0, plus the cos of x times the sine of pi by 2, which is 1. Sine x times 0 is 0. 1 times cos x is just cos x. So I've proven that this cofunction identity is true. Sine of x plus pi by 2 is equal to cos x. So you're going to have to trust me that all the other ones are true as well. So now we can use them. So the first thing we're going to do is evaluate or find an equivalent expression to tan of x plus pi by 2. Now tan is not one of my cofunction identities. It's only sines and cosines. So what I want to do is try to change tan into sines and cosines. Well, I know that tan of any angle is equal to the sine of that angle divided by the cos of that angle. So whatever angle's here, you just have to put over here as well. So this would be the sine of x plus pi by 2 over the cosine of x plus pi by 2. Now I can go to my identity sheet and pull out their equivalent identities. So the first one is that the sine of x plus pi by 2 is equal to positive cos x, and then the cos of x plus pi by 2 is equal to negative sine x. So then I'm going to write those in here. So we've got positive cos x on the top. We've got negative sine x on the bottom. Now, maybe that's done, maybe it's not. You know, again, multiple choice, you'll know if it's done, or answer in the back of the book, because cosine over sine could be equivalent to cotan. So this could be negative cotan x. So either one of those, they're both great, right? It kind of just depends upon what the textbook wants. And again, 7.3 will get direction. All right, so I recommend pausing the video and give this one a go before you try the quick check in the textbook. So hopefully you did pause the video and you're coming back. So I'm going to remember that secant of any angle is equal to 1 over cos of that angle. So I'm going to replace this with 1 over the cos of x minus pi by 2. Then I look up my cofunction identities, and I see that the cos of x minus pi by 2 is equal to positive sine x. So then I'm going to replace that cos x minus pi by 2 with positive sine x. So maybe I leave my answer like that, or maybe I rewrite it as cosecant x. Either one would be great.